everyone, I'm Winnie. Today I'll show you how to solve a word problem about fractions and ratios. First, I'll read the problem. In a bakery, the ratio of the number of apple pies to the number of croissants was 5:3. After 6 apple pies were sold and 6 more croissants were made, the ratio became 7:5. How many apple pies and how many croissants were there in the bakery at first? Okay, I'll give you 10 seconds to brainstorm about how to solve this problem. Okay, you ready? I'll show you 2 solutions about how to solve this problem. The first solution is about making an equation. The most important part about the solution is making an equivalent relationship. Let's read the problem again. In a bakery, the ratio of the number of apple pies to the number of croissants was 5:3. So what does this sentence tell us? Well, it tells us that the ratio of apple pies to croissants was 5/3. We can write A for apple pies and C for croissants. This equals 5. Since 5/3 is in simplest form, it means that A over C simplified equals 5/3. We can let X be the common factor between A and C. Now we know at the beginning, we know that apple pies equals 5x. We can write, let 5x be the number of apple pies. We also know 3x is the number of croissants at first. We write, let 3x be the number of croissants. Okay, at first we know for every 5x apple pies, we have 3x croissants. Now let's look at the next sentence. After 6 apple pies were sold and 6 more croissants were made, the ratio became 7:5. So what happened? Well, we can subtract 6 from 5x because they were sold and add 6 to 3x because more were made. This equals to 7/5. This is our equivalent relationship. We can now solve for x. We can cross multiply and get 5 times parentheses 5x minus 6 equals 7 times parentheses 3x plus 6. Using the distributive property, we can get 25x minus 30 equals 21x plus 42. Now we move the numbers with the factor of x on one side and the numbers on the other. We get 25x minus 21x equals 42 plus 30. Then we get 4x equals 72. So x equals 18. Now at the beginning, we let 5x be the number of apple pies. So for the number of apple pies at first, it is 18 times 5, which is 90 apple pies. And at the beginning, we'll also let 3x be the number of croissants. So we get 18 times 3, which equals 54 croissants. These two are our answers. We will now talk about the second solution. The second solution is about the concept of fractions. We know that the number of apple pies and croissants combined is the total number of pastries. This total is divided into 8 equal units, and apple pies take up 5/8 of the total. I'll write A for apple pies. We also know that croissants take up 3/8 of the total. I'll write C for croissants. This is at the beginning. Now let's look at what happened. After 6 apple pies were sold and 6 more croissants were made, the ratio became 7-5. Since 6 were sold and 6 more were made, did the total change? No. But the ratios changed. So now the total is divided into 12 equal units. And apple pies took up 7/12 of the space. Croissants took up 5/12 of the space. We can now solve for the difference between these fractions. Note that this is before. And this is after. To make finding the difference easier, we will find for the least common multiple. We can solve for it. We can see that it is 24. We can now change the fractions so they have a common denominator. We can now see that for apple pies, the number of apple pies at first is 1 unit more than the apple pies after they were sold. So how much is 1 unit? Well, when we look at the problem, we can see 6 apple pies were sold. This means that 1 unit equals 6. Likewise, when you look at croissants, we can see the croissants at first is 1 unit less than the croissants after. This is because 6 more croissants were made. So we also get 1 unit equals 6. Now, apple pies at first, number of apple pies at first took up 15 units. So for apple pies at first, we can write 15 times 6, which equals 90 apple pies. For croissants, we can see that the number of croissants at first is 9 units. We can write 9 times 6, which equals 54 croissants. We also get 90 apple pies and 54 croissants using this method. In conclusion, this problem can be solved using different methods. Right, Gavin?
Yes, you are correct.
Thank you.
Good job, Winnie. You have correctly applied concepts and ideas on how to solve this problem. Indeed, there are not just one, but many different types of solutions on how to solve just one mathematical problem. For example, in this problem, we presented two solutions. One uses an understanding of ratios and on creating equivalent relationships. The other uses a deep understanding of the meaning of fractions.
If you like this video or think this video helped you solve this problem, please like and subscribe to our channel.
Thank you for watching.